you're there. So here we go. Today we're going to learn about nested loops. Nested loops are pretty darn cool. The way a nested loop works is that the inner loop, there's an inner loop and an outer loop. And the inner loop runs, uh, like in this case, 5 times, and then goes back to the outer loop. And then the inner loop will run 5 times back to the outer loop. Inner loop will run 5 times back to the outer loop. And the number of times the outer loop is dependent on that first conditional. So you can see here that they use the structure where row starts at 1 and goes through and includes 3. And again, for the second loop, it starts at 1 and goes through and includes 5. They could have also put a 0 there and gotten rid of the less than and equals to and just gone less than, and it would have had the same result. That would be 3 rows with 5 items in each row. So think of it like chairs arranged in a movie theater. You would have 3 rows, and within each row, you'd have 5 chairs. And that would be represented by the star. And so that star would be printed 15 times. That's the way that inner and outer loop work. It's a pretty cool construct. The most common error new coders make when writing nested loops is that they get their nesting structure all messed up and their nests, their streams cross, so to speak, and that can cause disasters. So using your indenting tools and keeping those loops lined up and structured correctly is really important to make sure those nested loops behave as you expected. We're going to watch a College Board explanation of the loops, then we're going to write some loops, then I have an assignment with some loops, or we're also going to do some multiplication with some loops. So kind of a cool little lesson. First, the video.
Hi, everyone. My name is Sandy Chaika. I teach at Riverside Brookfield High School just outside Chicago. And I'm really excited to be here today to have a little bit of fun with CS with you and talk about nested iteration. So in today's video, we're going to look at the relationship between the outer and inner loops and how those are executed. So what exactly will we learn? Well, the goal is that you'll be able to represent nested iterative processes. In order to do that, we need to know a couple of things. First of all, nested iterative statements are iteration statements that appear in the body of another iteration. In other words, it's a loop inside the body of another loop. And one of the key things we need to know is when a loop is inside another loop, that inner loop must complete all its iterations before the outer loop can continue. So let's unplug it for a minute and look at this from a perspective that's not necessarily computer science. So believe it or not, you've already experienced nested loops in your life every time you look at a clock. So when I put up the picture, focus on the seconds hand. So in this photo, you will see that we have a small seconds hand. The middle size is is the hours hand, and the big one, the largest one in pink, is the minutes hand. So when a clock is moving, you will see the seconds hand slowly make its way around the clock until we have one full loop or 60 seconds. So what happens then? Well, because we did one full loop around, now the minutes hand is moving 1 minute forward. This will continue to happen. Every time the seconds hand moves around, the minute hand will get another minute under its belt, and eventually the minutes will go all the way around and the hour hand will move one up. This is one of the things that we see happening over and over and over again. The minute hand increases by 1 and the second hand starts looping all over again. So a better way to think of this is if we're looking at a timed mile run. So we might start a stopwatch, and at the beginning of the race, the gun is going to go off and we have the time 00, and the time starts passing. So 1 second, 2 seconds, 3 seconds, 4, 5, 6, all the way up, eventually 58, 59. Now we've gone through a whole minute. So The outer loop increases by 1, the minutes increase by 1, and that resets the seconds back to 0. Now the seconds have to start over again. So we see 1 minute, 101, 102, 103, keep going over and over and over again until we finally get to almost 2 minutes, 158, 159. That inner loop is done. So the minute goes up by 1 and we reset the seconds back to 0. This will keep going on over and over again until the race is over. Now, if you're timing something like the marathon or just a really slow runner like me, you might actually get another loop that would be the hours. And so when the minutes hand gets through a full loop, meaning it would go all the way up to 59, when it gets to 60, the hours would go up by 1 and minutes would reset. So let's take a look at an example that actually involves computer science. So in my example, I have a loop where the loop control variable for the outer loop is called outer, and it's starting at 1. It'll continue while outer is less than 5, and that control variable will increase by 1 each time. My inner loop has an inner loop control variable called inner that starts at 1, will continue as long as we're less than 3, and increase each time. So every time we're in this loop, it's going to print out the inner value and continue. So pause the video for a moment and see if you can figure out exactly what's going to happen and what the output will be. So hopefully you had a chance to look at that. So knowing that's what you did, let's take a look. Outer equals 1, 1 is less than 5. So I'm going to go in my inner. Inner is 1, which is less than 3. So I'm going to print out inner, which is 1 and a space. Notice it's just a print, so I'm going to stay on the same line. Inner goes up by 1, which makes it 2. 2 is less than 3, so I'll go back in and print 2 with a space. Inner increases to 3. 3 is not less than 3, so this inner loop is complete. This line here, system.out.println, will just bring me to a new line. And outer will increase by 1. So that first iteration of the entire inner loop gave us a 1 and a 2. Now outer becomes 2. 2 is less than 5, so I'm going to go back in, and this inner loop starts all over again. 1 is less than 3, we print out 1, inner becomes 2. 2 is less than 3, so I print out 2. Inner becomes 3. 3 is not less than 3. So my inner loop is over, and it produced again a 1 and a 2. Outer goes up by 1 to make it 3. 3 is less than 5. So I'm going to repeat again. So we already know now the inner produces a 1 and a 2, so it's going to do that again. Outer becomes 4. 4 is less than 5, so we're going to repeat our inner, that 1 and a 2, one more time. And now outer becomes 5. 5 is less than 5. So I'm done. If the outer loop is done, we can no longer execute the inner loop. When the outer loop is done, the entire nested loop is done. And so that is all the code will actually output this time. So hopefully we have some takeaways from this video. We want to know how to represent nested iterative processes. And that means knowing that nested iterations are basically just a loop with another loop in the body. And when a nested loop is inside an outer loop, the inner loop must complete all its iterations before the outer loop can continue. So we're going to look at more examples of code with nested loops in our next video. And just to get you a little excited for later in the year, I want you to know that nested loops are going to really be used a lot in Unit 8, and you're going to become absolute experts. So thank you so much for watching this video. I look forward to seeing you in the next video.
You'll either become a nested loop expert or you will despise nested loops. I'm not sure which one, but nested loops are tons of fun. Just ask Hitler in his famous APCSA video. The loops are tricky. Now, it is kind of fun to see what. Um, Check this out from CS Awesome. Doesn't this look familiar? This one in less than or equal to 3. And the only thing different is they used a space there instead of a star. So I guess the CS Awesome is used by a lot of people to do that. And what I'm going to beg you to do is I'm going to beg you to go to this link, and I'll put it into the chat. And I'm going to ask you to actually do this together. The link is in the chat. And go to that page. And when you go to the page, you'll be up at the top of the page. And the actual activity, I should have put that right in there. The actual activity is this first coding exercise. So you have to scroll down a little bit, not a lot. And it's asking you to change it so that the rectangle has 10 rows and 8 columns of stars. So when you run it now, it's going to be like 2 and 4. Oh, sorry, 3 and 5. Why is that? 1 to, equal to 3. Yeah. So there is that one. Now, can you change it so that instead of instead of 3 and 5, it's 10 and 8? What do you change? How can you make it go so that instead of being 3 and 5, it's 10 and 8? And then when you hit run, it should like go. Anyone having problems getting there? The screens I see look like a lot of people are there. So I see some, it's on chapter 4 or topic 4, lesson 4, nested loops 4. And if you just click on the link in the Meet, it will take you right there. And some of you, it's struggling, isn't it? Sorry. So in the Meet, there's a link. All right. It wasn't a trick question. 10 rows and 8 columns. They have the equal sign there. Let's see if I got it. Checking that it contains 8 columns. Oh, look at that. Hey, look at that. I'll highlight the lines that you need to change in case you're struggling a little bit. The way this code works is this nested loop runs over and over again. So it's going to run 10 times the way this is set up. And this one is going to run 8 times. Just as an FYI, I typically set up my loops, and most people I know set up their loops like this. I don't know, just a matter of style. Oops. Why didn't it work? 10 rows. 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I do have 10. 10 rows. Huh. 7, 8, 9, 10. I wonder why it said it failed. Let me try it again. Checking that the code contains 10 rows. Really, it does. Huh. Well, that's interesting. But wait, there's more. Common problems that occur, which just happened right there, which is an interesting OBOB because the output is correct, is these OBOB errors. And making sure you can figure out how many times each thing is going to run is a non-stop off by one bug challenge. So in the next section of that textbook, there are some interesting OBOB questions I challenge you to experiment with right now. And just scroll down your page in CS Awesome and answer the two OBOB questions and just get a grasp of how that one works versus the 0, how the greater than or less than works versus a less than or equal to. So see if you can figure out those two OBOB challenges. Once you have those two OBOB challenges done, would you mind just writing OBOB in the chat window so that I know you have completed the two OBOB challenges? And it's fun to say OBOB, but it's kind of fun to type OBOB as well. So once you've completed those two OBOB challenges, if you wouldn't mind throwing down an OBOB, that would be awesome. We got some people finishing up their OBOBs. Good. More people OBOBing. Oh, Bob. By the way, OBOBs throw me off all the time. Whenever I get output that isn't quite what I want, but really close, I just start doing my OBOB checks. Replacing the 0 with a 1, replacing the less than with a less than and equal to. The going backwards one is really tricky. All right, I've got a lot of OBOBs, and I know I don't have them all, but I am going to move on and just beg you to come back later and look at all the different activities there are with nested loops. Nested loops are a big deal. They will come back around and around and around. So if you can get them now, it will really make your life easier. I want to, I want to do a nested loop challenge that I welcome you to do as well if you'd like, or to watch it later and do it in the video. But I am going to show you a replit challenge where I'm going to make a nested loop I don't have time to wait for everyone after it. I'm just going to do like a demo and explain it. But I want to show you the nature of the project and just talk about it a little bit. What the nature of this nested loop challenge is that you have a number of a row variable, a column variable, and a string variable. And what you want to do is you want to call a method called draw rectangle that when you ask for 3 rows, 5 columns, you can provide it a string and it would output that string repeated in 3 rows with 5 columns. Again, 2 and 4 and 6 and 2 are some examples of what this problem would ask you to do. And so I'm going to share my tab. And I am going to write that code, but I'm going to just do some stuff to make it a little easier for everyone to see. Hopefully you can see that. And I also want to review this method call. In your free response questions on the AP exam, they are often written in a way where they ask you to write a method or a class. So you're going to be asked to do those two things, and we haven't started classes yet, but we definitely have covered methods. And the way that works is they will often give you the base code, like here is the main method doing something, and here is the method. The method has 3 parameters, a row, a column, and a string. And again, the row is set to 3, the column is set to 5, and the string is set to be this star. And in this particular method, they don't want you to return anything, so it's void. They want you to actually draw that right here in the method. So you're going to be drawing whatever that string was passed. So the string that was passed is just this one. So I'm going to just draw the string, and I haven't done any looping yet, but let's just see what that output is. So I'm going to code a little bit, and I'm going to test it. So right now, I should just have 1 star, and that's what it outputted. Now, I'm going to try to write the rows. So I'm going to create that first for loop. And instead of using INTI, which is a nice convention, for this particular problem, I'm going to go INT row. And notice that this row will not interfere with this row because this row falls out of scope here, and the value passed is actually just an R. So the value of row, the variable, is passed, and now it's called R, which is really interesting, right? So int row equals gets 0, and then I'm going to have it go as long as it's less than the value passed, and then I'm going to go the loop controlled variable is row, so it's going to go row plus plus, and in this case, it should now print 3 stars. Let's see if that works. One after another in 3 rows. 3 rows. Absolutely perfect. Just what I wanted. 3 rows. Just to test it, I'm going to change this to 10 to make sure I get 10. And 10. I'm just going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So that worked just like I expected. Now, that's your traditional for loop that you've gotten good at writing. Now, just for style, I am going to add the proper formatting, which you notice was missing there. Oops, lost my thing there. Was missing there. If you just have one line, just like an if statement, it works, and I shouldn't have done that. That was sloppy coding on my part. I was taking a shortcut there. Now I'm going to do my inner loop. I'm going to say for, and this is going to be the column, less than C, which is referring to this C here. And then I'm going to iterate my loop controlled variable, which is column. And again, it's going to output this, but here's the trick. Well, let's see it in action. It's the stars I'm going to have. It's more like a multiplication problem. I should have 15 stars because, or 15 lines now because of the way this works. But you'll see what happens there. That's not the output I intended. I wanted 3 rows with with 5 in each column. So I'm going to switch this to a print statement. Now, when I do that, oops, I'm also, sorry, I was sloppy again. It does work because it's just one line, but again, it's sloppy. So especially when I'm doing a demo for the class, I should use good style. There we go. So run it. And again, now they're all in one line, and that's not what I intended either. So here's the trick. I'm going to reset each line with I can just do that, or I can do that. Either way works. I'm just going to reset the line at the end of the loop. So when this loop runs, in this case, 5 times, it's then going to reset the line. And now I'll have the correct results, I hope. Perfect. Let's test it by changing some of the stuff around. Let's go 6, 4, and change it to a $sign. And notice I'm 6, 4 with a $sign. So this code is somewhat useful. So I now have this code here. If you want this code, I would welcome you to take a copy of it. I'm going to put it into Google Classroom here. That link would get you a copy of that code. That's a nice nested loop to have in your inventory of code that you have that you can use, copy, check out, and see when you need to solve problems with loops. There's at least an example problem there that I hope you're able to access if you click on that link. Hopefully you get then, and you'll have that code available to you, and you can use it if you want it for anything. It's there for you now. All right, gonna switch back to the presentation. And one last topic before I give you your assignment. Code analysis becomes a really big deal in data structures. So if you have any friends or you know people taking data structures who have taken data structures, a really big deal is calculating how long things will take and then coming up with more efficient ways to solve the problem by writing the code different, by using a different data structure. For example, you can really change the runtime of a process. And if you're Google and you're running billions and billions of processes, those small efficiencies add up to big savings. So one of the things you'll be asked at this level to do in Java is calculate how many times a nested loop would run. And the quick and easy answer for that is to multiply the inner loop and outer loop together. So the number of times the inner loop runs times the number of times the outer loop runs. So let's look at the triangle problem. The way the triangle problem would work is let's imagine I set up a number and I started at 1. And each time I go through the loop, right now row is 0, column is 0, it's going to put out the number 1 and then add a space. Then it's going to increase the number by 1, so the number is now 2. And now the column has increased to 1. And it goes through this 5 times. Then it drops and it's going to make a row and then come back through here and go through this another 5 times. And then it's going to output, and in this case, 6, 7, 8, 9, 10, and then make another row and do that all the way until it reaches the number 35, because 5 times 7 is 35. By the way, when you go to data structures, you'd call this quadratic because you're multiplying the 2 loops together. So whatever the time of this first loop times whatever the times the inner loop, times whatever the time of the outer loop, and you'd have a quadratic that's how complicated that algorithm is. That's how long that algorithm will take to run. My challenge to you is to look at the circle problem. And with the circle problem, I'm going to represent it with a capital O. What is the number of times that loop will run, or what will the number be, the last number displayed be? So look at that O problem and calculate what O would be. Type it into the chat window and hit return. What will the big O be of that problem? Come on, big O people. The 3 and the 6. What's the time complexity of those loops? Anyone brave enough to be the first? Oh, judging by the lack of people typing into the chat window, I was not clear. So I'm going to go over it again. Sorry about that. It's good to know. The question I'm asking is, how many times will this loop run? So this inner loop will run 6 times. The outer loop will run 3 times. So 6 times 3 would be 18. You multiply the inner loop times the outer loop, and that gives you the complexity. So the answer is 18. So it's inner loop times outer loop, and that gives you the time complexity. I made it more complicated than it needed to be with my big O story there. But wait, there's more. Let's do the WASD key. Okay, that's my attempt at a little joke. All the arrows pointing all the different directions. So for WASD, what would be the number of times that would run? Nice. Inner loop times outer loop. And I'm not sure if anyone is brave. For the people, most of the people who didn't answer, would you mind, is someone brave in saying I'm lost, or are people just not in the meet, or I'm just wondering if there's confusion about that? Because I'm going to explain it again, but I'm not sure why. I don't know if people are lost or they're just not there. 2020. So let me explain how the WASD key problem works, which is the arrow pointing 4 different directions. Maybe that's where the confusion was, my bad joke. So what will happen is first the for loop the outer loop will enter, and it's going to run 2 times. But the first time, as it goes into the for loop, this runs, and you can see it goes 5 times. So it would print 1, 2, 3, 4, 5. And then it's going to slide to the outer loop, which runs twice. So then it's going to run again 6, 7, 8, 9, 10. So that's being outputted here. Oops, the num and then the output. So the inner loop runs 5 times, the outer loop runs 2 times, and that's the 10. Anyone brave enough to put lost in the chat window? I'm not sure. Last one is the thought bubble. The thought bubble. How many times does the thought bubble code, that nested loop, how many times is that running? Yes, it's good to see the meaning of life scrolling across the screen. For Hitchhiker's Guides to the Galaxy fans out there, you think that's hilarious, I hope. But yes, the meaning of life right there, 42. So the answer to all questions right there. So again, that has to do with just multiplying the 6 times the 7. That's the number of times that loop would run. Now, I thought the assignment was pretty cool. For those of you who like the Turtle Graphics activities, you're going to love this activity because you're going to make an inner loop where you make the square and an outer loop where you rotate the turtle a little more and then make another square. which kind of makes it look like a snowflake, which is pretty darn cool. And so your assignment today in the last 20 minutes, hopefully that's plenty of time to at least do one of them. If not, if you want that advance and want to do them both, that would be awesome. But is to make a cool, and let me zoom out, a cool snowflake. Now, first you got to, oops, this is going slow, sorry. First, you got to get just that square going. But now look at how you make an inner loop and an outer loop, and it won't be complete. So you've got to figure out how to finish that puppy up, which is really, really easy. It's just changing some numbers. So that one's not too bad. Then there is a harder one that is worthy of moving your grade to advanced. So what I have in Google Classroom is another challenge, the 4-4 Snowflake Challenge. And I ask you when you get done to just complete the Snowflake Challenge in the Snowflake Google form. And when you have all that done, feel free to double check that you've turned in all your other forms. I am missing some people's forms, and I'm going to grade the 4-3 challenge here today, right after this class. So let's get that in if you haven't done that. And then do the 4-4 challenge. And if you're really an overachiever, I have added the project into Google Classroom. So feel free to look over that project, which we'll be going over tomorrow. And I'll be giving you work time throughout the week while also doing short review activities to prepare for the AP exam as well. I'm going to stop the recording there. That's the end of the lecture. But does anyone have any questions